Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And welcome to my fifth lecture. And today, our topic is space air distribution. Alright, let's look at this figure. And first, you have to know that condition points of a typical HVAC system are the location of air conditioning state within thermodynamic process. So in terms of thermodynamic process, we use psychrometric chart to simply design our supply condition, and that I will talk about that much more in later slides. And the most important location of air conditioning are design condition, written condition, outdoor condition, mixing condition, and also supply air condition. And there are certain conditions that are already known, such as outdoor condition, room condition, room or written condition are the same basically, and mixing condition also known, and unknown is supply air condition. So based on this figure, we know that we have outdoor air, the incoming outdoor air, and at this point, just before the airflow enters the air handling unit, there is a mixing point where the written air will come to this point, mixed together with the outdoor air at certain proportion, and enters the AHU, and it is conditioned in this part, and it will be supplied to the conditioned space, and the written air, some portion will be exhausted to the outside, to the ambient, and portion of it will go back as written air and mixed with the outdoor air, and the cycle repeats. Alright, so now basically there are three ways whereby the conditioned air is introduced in the room or conditioned space. Like we just discussed, we have outdoor air, we have mixing air, and we have written air. And written outdoor air is 100% fresh air supply, and mixing air is a combination of the written air and also the outdoor air. And we know that the written air is the air returns from the room space, and of course without outdoor air. And every conditioning point represented by two properties of air, which is the temperature and also the relative humidity. The indoor air temperature, indoor air relative humidity, outdoor air temperature, and also the enthalpy of outdoor air. Right, now let's look at this figure. Right, so we have conditioned space, we have several points whereby there is exhaust air, outdoor air, mixed air, and also the supplied air. Here is a cooling coil and also the heating coil. And it is very important to know that there are two types of heat that has to be overcome in order to cool a space, which are sensible heat and also the latent heat. And there's some of supplied air volume. Q is volume in this case, and we know that the volume of supplied air is equals to the sum of the outdoor air volume plus the return air volume, which is in this case in feet cubic per minute. Right, and the quotient of the volume of every type of air, we have for here in this case we have 100% return air from the room, or you can also say that it is room air. Then 20% of it will be exhausted to the ambient, 80% from it will be returned to the AHU, and before AHU it is mixed with the outdoor air, and as the exhausted air is 20%, so there is 20% of outdoor air has to be used to replace the quotient that is exhausted to the ambient. So we have here 20% of outdoor air plus the 80% of the return air, and it will be mixed, and it will go through again through AHU to be conditioned before it is supplied to the room. And it is very important to note that the total heat is equals to the sensible heat plus the latent heat. So both types of heat must be overcome in order to cool any space. And this, to recap again from thermodynamic, so sensible heat, and in this case this is small q, not the big Q, so the sensible heat, which is measured in kilojoule per second as a SI unit, is the amount of heat changed due to the change in temperature of body or system, and it can be calculated by using this formula. We have QS, or sensible heat, the specific not specific, this is rate of sensible heat, is equals to mass flow rate times the heat capacity at constant pressure, because the air is allowed to expand, so it is Cp times the difference of temperature, and also equals to the mass flow rate times the enthalpy, specific enthalpy difference. And latent heat, whereby on the other hand, latent heat is the amount of heat related to changes in the phase of system by identifying the difference in humidity ratio, and it can be calculated by using this formula. The rate of latent heat is equals to mass flow rate times the difference in the humidity ratio. So we have no units for this term, because kilogram over kilogram, it cancels out, times I, whereby IFG is the enthalpy difference of the mixture in kilojoule per kilogram. So at the end you will have kilojoule per second as the unit for latent heat here, or is also equals to watt, right? Okay, now we have several types of air just now that I have mentioned about. So now the most important thing is to know the supply air condition, but before that we have to understand what is the mixing condition of the air. And mixing condition is a function of the outdoor air conditions plus the written air condition and the quantities of the outdoor and written air, and it depends on the ratio of written air condition and also the outdoor air condition. And for every condition, the relative humidity and also the temperature, it can be determined by using this formula. So X is for any condition of the mixed air. MA is mixed air. X can be temperature, X can be relative humidity, for example. So we have the volume of the outdoor air times the property. I just give an example to make it easier for you to understand. So let's assume that this X is temperature here. So the temperature of the mixed air is equals to the quotient of the outdoor air times the temperature of the outdoor air plus the quotient of the written air times the temperature of the written air divided by the sum of the outdoor air and written air quotient, whereby it should be 1, right? Or you can, as simplification, so you can use this formula. We have temperature of the mixed air dry bulb is equals to, if your outdoor air is 20%, so we have here 0.2 times the temperature of the outdoor air plus 0.8, which is 80% of the written air, times the temperature of the written air. And it can be plotted after connecting the states of design condition and outdoor air condition by a straight line. Right, so in the psychrometric chart, you can first plot the two condition, the known condition, which is the room condition and also the outdoor condition, and connect these 2 points with one line, one straight line. And by using this portion, so we know that the ratio of the outdoor air to the written air, so you can actually measure the lines and then draw the mixing point by using the ratio. Okay, so we can see closely after this in next slides. And there are several factors which are very important for air conditioning process. So you have to consider these three, which are room sensible heat factor, grand sensible heat factor, and also bypass factor. Okay, what are they? So room sensible heat factor is the ratio of the room sensible heat to the total heat, and we know that total heat consists of sensible and also the latent heat of the room. Simplified in the formula, so you can see here, room sensible heat factor is equals to the room sensible heat over or divided by the sum of the room sensible heat plus the room latent heat. And it can be plotted by using protector on the psychrometric chart, or by using sensible heat factor scale on the right side of the using a protector on chart, or by using the sensible heat factor scale on the right side of the chart. So I will show you after this. And after drawing on the scale on the factor scale, then you can transfer the line letter by using the parallel line to the room condition point. Okay, I'm going to show you step by step after this. So another one is grand sensible heat factor, and this GSHF is the ratio of the total sensible heat, which is room plus outdoor, to the total heat of the room plus outdoor. So basically GSHF is equals to the total sensible heat divided by the sum of the total sensible heat plus the sum total latent heat, and it can be plotted from the mixing condition to the saturation line. Alright, this is the factor, the factor that like a protector here. You can plot actually the sensible heat here, the room sensible heat here, room sensible heat factor, and transfer the line onto the points, the room condition. So let's say 1 is the room condition, then you have to transfer this line. So I mean the line must be parallel, and just draw it via room condition point. Right, this is another example whereby you can use this sensible factor, heat sensible factor, and again after do some calculation and you know the sensible heat factor for the room, then you can, for example here is 0.75, just draw a line and transfer this line to the room condition point. So here we call it room ratio line, so you can actually call it RSHF. Alright, another thing is bypass factor. So bypass factor is actually part of the total air through the coil which fails to come into the contact with the surface of the cooling coil. Therefore, the friction of the total airflow is bypassed, and the bypass factor can be calculated by using this formula. So bypass factor is equals to the supplied air temperature minus the apparatus dew point temperature divided by the subtraction of apparatus dew point temperature from the mixed air temperature. And so rearrange this so you can find the supplied air temperature by using this formula. Right, so this is basically the condition. For example, you have here mixed air point, so I just keep the room condition, the outdoor conditions. You draw a line. So after you draw a line, after you know the proportion of the room air and also the outside air, so you can plot your mixed air point. Then from mixed air point, you draw the grand GSHF, the grand sensible heat factor line, until it touches the saturation line, whereby you can get your apparatus dew point condition. So the temperature and also the of course it is 100% relative humidity. So from this you may get your supply point, supply condition, right? So just become, I'm gonna show you after this in next slides how to draw it step by step. Okay, now we have this basic diagram of the air conditioning cycle and its elements. Basically, I know you know already, but just to recap, again we have outdoor air and mixing box, whereby the outdoor air and also the return air is mixed before it enters the condition apparatus or AHU. Then we have living condition from AHU, and some of the air that are not in contact at all with the cooling coil, it will be go through this path as the bypass air, and the rest, the conditioned air, will go through a fan and will be blown to the space as a supplied air, and again the cycle repeats, return air comes again to the mixing box, and so on. And in air conditioning, the total air in circulation consists of about 90%, 80 to 90% of return air, which is recirculated, and the balance being outside air for ventilation, about 10 to 20%. And with the outside air being hotter and more humid, which means it has higher enthalpy than in the conditioned space, so its flow rate is kept to the minimum to reduce the air conditioning load. And here in the figure B, it shows the air conditioning processes on psychrometric chart, and we have talked about the ADP, apparatus dew point. We have talked about RSHF, which is the room sensible heat factor, and we also have talked about GSHF, which is grand sensible heat factor. And to understand this, so here we have room condition, so you already know the temperature of the room, the relative humidity, so you can plot it. We also know the outdoor condition, the relative humidity and also the temperature, so just plot it. Now connect these 2 points, and we also know the proportion of the return air and also the outdoor air. So this figure is not to scale, so just assume that the return air is 80% and the outdoor air is 20%. So the mix point, the mix condition should be around here. So just stick to this point so that it's easier to understand. So this is mix condition, and from here the mixture is cooled and dehumidified along the GSHF line right down to the point on saturation line. So here is the saturation line, whereby the relative humidity is 100%. So just extend this line until it touches the saturation line, and we will have our apparatus dew point. Okay, and the RSHF is calculated and is transferred, so you can use protector or use the sensible heat scale like I showed you previously, which is situated on the top left in psychrometric chart. So you can transfer the line onto the room design or room condition point. So just extend the line until it intersects with the grand sensible heat factor line. Then you will have your supply air condition. Okay, and like I said before, the mixture is cooled and dehumidified along the GSHF line right down to the point on the saturation line at which air needs to be supplied in order to extract both the latent heat and the sensible heat from the room at the required rates. This occurs in air conditioning apparatus here in cooling coil. The air leaving the cooling coil at a temperature close to apparatus dew point temperature is then supplied to the room, from which it picks up the room heat gains. And part of the return air is expelled to the outside and replaced by an equal quantum of outdoor air in figure A. Then the mixture is then ready to enter the cooling coil here in the condition apparatus. And the cooling coil is a heat exchanger, and today typically it is copper tubes and aluminum fins, and typically a refrigerant or brine or maybe water flow within the tubes, while airflow is without and through fins. Okay, and the air handling unit, or also known as condition apparatus, is a key element of the air cycle, and basic components of AHU are fan motor set, cooling coil, modulating phase and bypass dampers. These two are for control of airflow through the coil, mixing box with return air and outside air openings, and phase and bypass dampers are interlinked so that when the former is open and the latter is closed, and vice versa. And the arrangement provides control of relative humidity. And the mixture of outside air and also the room are cooled and dehumidified along the GSHF line, like I said before, here in the cooling coil. So it is called here. And heat from the room, which consists of, it consists of both sensible and also the latent, is picked up by air entering the room to maintain the room condition. So at point 1. Okay, so now we know how to get our supply air condition. So let's look at an example. So we have a room, and this room is to be maintained at 22 degrees Celsius dry bulb temperature. And if it is not mentioned here dry bulb temperature, then normally it means dry bulb temperature, right? So 22 degree C dry bulb temperature at 50% relative humidity, when the sensible heat gain is 10.8 kilowatt in summer, and the latent heat gain is 7.2 kilowatt. So draw and determine the following by using a psychrometric chart. The plant schematic is shown here. So you have to find the mixing point temperature, and you have to determine the supply air temperature. And it is also given that the outdoor condition is 28 degrees C and it has 80% of relative humidity, and the outdoor air and return air ratio is 20% to 80%, and the ADP is also given is 8 degrees C. First, what you have to do is plot the room condition and also the outside or outdoor condition on the psychrometric chart. The condition is already given. So join these 2 points from the room condition to the outside condition. Then just find the mix point, because we know the proportion of the outside air to the room air. So we have here 80%. Sorry, this is quite wrong. So actually the point should be a little bit here, because we have 20% of outside air and 80% of room air. So approximately here. And then just find the room ratio. Okay, maybe some of you have question. How do we actually draw the mix point condition? Okay, because we have this line, this straight line, and we know the proportion of the room air or return air and also the outside air, and we know it is 80 to 20. So just measure this line. For example, it has 8 centimeter length or 10 centimeter length. Then the side, so the 80% is the return air, so 8 cm from the room condition is the mix point, is a mixing condition, mixed air condition. So next step is to calculate the RSHF, because we know the sensible heat and also the latent heat of the room, so you can just add it up. So you have 18 kilowatt in total, and we know that RSHF is equals to the sensible heat over the total heat. So just divide 10.8 of the sensible heat to the total heat, which is 18 kilowatt. So you will have 0.6 in this case. Just plot a line to 0.6 in this sensible heat factor. So just draw this line and transfer this line, so parallel to this line, to the psychrometric chart via the room condition. So just draw the line via the room condition. So now you have this line, and just now we also have the mix point condition. So just draw a line, because we already know the apparatus dew point temperature, which is given, which is 8 degrees C. So just plot it here and connect these 2 points, the mix condition with the ADP. So now you already have this line. So let's look at next step. Okay, now it's bigger, right? So you can see better. So we already have this 1, 2, 3, 4 points, and we also we already have the RRL or also known as RSHF, room sensible heat factor, by the calculation that we have done just now. Now, to plot the supply air condition, this is the last step. So we have to reheat. Actually, from the apparatus dew point temperature, we have to reheat the air to the supplied air condition. And we know in the psychrometric chart process, reheating only, we will draw a horizontal line via the ADP, the apparatus dew point, until it intersects the RSHF line or RRL line here in this case. So draw a line horizontal via ADP, and where it intersects with the RSHF or RRL, that is your supply air condition. Now we have our supplied air condition. We can read the temperature, the dry bulb temperature, and we also know the relative humidity of the supplied air, which is about 55% in relative humidity, and also 15 degrees C for the temperature. So actually there is no end to education, and it is not that you read a book, pass an examination, and finish with education. Actually, it's the whole life, from the moment you are born to the moment you die, is a process of learning. So by Jiddu Krishnamurti. So keep learning. Assalamualaikum warahmatullahi wabarakatuh.